I'm a certified SolidWorks expert, and I'm also a certified simulation professional with SolidWorks. I have like 25 different certs. We have to get them for work here at TriMech. So I'm on my way to becoming an elite. I think we need to have 31 certs for that. So that's a lot. I've been a mechanical design engineer prior to teaching at TriMech for about 15 years in a bunch of different industries like water hydraulics, supercritical CO2 extraction. My favorite hobby is 3D printing. I would call myself a little bit of a nerd with 3D printers. I have 14 of them at my house, and I like to like print things that I draw in SolidWorks. Like I have an adult Nerf gun that can shoot a Nerf dart over 100 yards. I have some crazy random projects. So it's fun times. So today we're going to see all of the different mates in the mechanical tab. And we're going to see all of the different mates that you have available to you in the advanced mates tab also, and how to use them. Then I'll show a tool called physical dynamics for hard to mate mechanisms, like this set of, I think it's called a Geneva wheel. This would be pretty hard to mate without, well, I don't even know what kind of mates I'd use to see that move. But we could turn on physical dynamics, and whenever the parts crash into each other, SolidWorks will make them move one another when that tool's on. So it's great for testing out mechanisms that might be hard to mate down otherwise. Now, the first demo that I'm going to show here is this unit. In this demo, we're going to learn 4 different things. We're going to learn about the cam mate. We're going to learn about the slot mate, the hinge mate, and we're also going to see how to add a belt chain feature into a SolidWorks assembly. This is extremely useful if you want to figure out how long of a belt you need when you're manufacturing something. It'll help you figure that out, and you can give it an exact size also. So we'll go into that. That is an assembly feature that you can add inside SolidWorks for the belt. It's a little bit beyond the mates, but it makes the pulleys move together. If you move this top pulley, it'll move the bottom one because of that. So I figured to include that as well. All right, let's jump in. I'm using SolidWorks 2025 Service Pack 0, by the way. I'm just gonna double click or hit R. If I double click, it'll bring up my home screen. If I hit R, it would bring up my recent documents, and I can see all the other files I was in recently. So let's see, where's the first one here? Ah, there it is. Now we're gonna start off with the hinge mate. I have a bonus item to talk about after I show the hinge mate that is a little simpler called smart mates, but let's show the hinge mate first. I have this part here that I need to hinge about this hole. So I'm going to go into the mate tab. Anytime that I'm going to do a mechanical or an advanced mate, I like to come into this tab and click the type of mate that I'm going to use. First, I can see I already have some face pre-selected in here. So I'm going to delete that out of there. And then I'll tell it that I want to create a hinge mate. The reason I like to click it first is because sometimes you get unique selection windows. You can tell what you have to select better if you click the mate first. So we need concentric selections. That means the holes that make the hinge line up. So I'll grab this hole and this hole. And now we need the coincidence selection. So that's the faces where things are touching. So that'll be this face and let's say this bottom face there. And you can see the component moves into position. If I hit the green check and green check again, we have a hinge mate. It's locked down and it just hinges by that point. Now, you could do a similar thing by adding two separate mates. You could add a concentric and a coincident mate and make this happen, but it might be a little easier to use the hinge mate. Let me show you how to do this with the smart mate tool, because I think it's probably the fastest way to do it. It's going to end up adding a concentric and a coincident mate all in one go. Now, to initiate the smart mates, you just hold down your Alt key and click and start to drag something. So let me delete this hinge mate out of here. I'm just going to delete it off of the feature tree. We'll move this back into a random position. And if I want to mate this circular face, this circular area over to this one, there's a really cool smart mate that will add two mates at once. We can get both of our mates just with a drag and drop. If I hold down Alt and I grab a circular edge, so this edge here, and click and start to drag, you can see there's a paper clip next to my cursor. That means smart mates have been engaged. Now, if I drag over a hole, you can see I'll get this little symbol that looks like a post going in a hole. That's going to add two different mates just because I held down the Alt key and drug it over there. Now, as soon as I let go, it adds a concentric and a coincident mate. And same effect as the hinge mate, but it's done with some simpler mates. So I like to show the smart mates because the peg and hole smart mate is my favorite way to save time. I do it with fasteners. If I have a bolt or something, I grab the circular edge on the underside of the bolt while holding the Alt key and drag it over the hole and let it go. And there it is. All right, now let's go on to the next thing. So let's put a belt in here. Let's say we want to put a belt that goes around here, gets pushed by this tensioner pulley, and then around this bottom pulley. And we want, whenever I move one of these pulleys, we want it to move all of the different pulleys as if there's a belt there. In order to do that, we need to go to the assembly features. The last one on the list, belt or chain, is a type of assembly feature you can add. It wants you to select cylindrical edges of your pulleys. So if I grab this outer edge, and then I grab this outer edge, and this outer edge, you can see it puts a little arrow at each of the pulleys in case I want the belt to go on the other side. If I want the belt to go on the other side of this pulley, I just have to click this arrow. And we can see what this belt's length is that it had to put in here. Over in the feature tree, see how it says the length of the belt, 2009 millimeters. If we want to make it a certain length, we can tell it that our belt length is driving. And I could maybe say, oh, this belt is 2050 millimeters long. It's going to move this arm to whatever position it needs to be to make that happen. Actually, maybe let's say it's 1950 long. 1950. And when we get out of this, oh, there you can see it updated a little bit. That's where this arm's position has to be for that kind of belt. Now let me talk about the other options in this property manager before we get through it. So if you click on any of the individual edges, it tells you how big around those were. If you wanted to change that for the gear ratio, you could change this value just by clicking an edge and typing in a different value. And you could hit flip belt side, which would be the same as grabbing that little arrow out on the screen to move it over. If you want the belt to be located in a different plane than where you picked, you can pick a belt location plane. Maybe in this case, we want it to be in the center of this pulley. I'll grab the belt location plane. I'll find the pulley on the feature tree. I think it's the right plane. Let's see. Oh, no, not that one. I'll delete that made out that out of there. It's maybe the front plane. Ah, there. That's the wrong one too. Okay, it's the top plane. And now you can see the belt's gonna sit in the middle and line up with the top plane of that pulley. The last thing to mention is if we tell it use belt thickness, we can punch a thickness in for this belt. Maybe it's 5 millimeters thick. And the last, also, if we have engage belt checked, then when I turn one pulley, the rest of them will turn. And if I have this create belt part checked, it'll make a sketch in the assembly file that we could make a part from that looks like a belt. If we really want to have a belt in there, we can use that sketch, make a top down belt part, and it'll update also if we change any of this stuff. So let me just go ahead and hit the green check. Because I told it to make a belt part, it asks me for a part template also. And now you can see a sketch in there that looks like our belt. And we also have a new feature in our assembly. If we look at the bottom of our assembly tree, there's the belt right here. Now, if I start to turn a pulley, we can see all of the rest of the pulleys turn as if they're connected to the belt. Pretty cool. All right, now we've got a couple more types of mates to do. So I have a cam here, and I want this follower to follow the cam as this cam goes around. Well, I can use a cam mate. I'm going to go up to the mate tool. And I'll choose the mechanical mate tab. And I'll select the cam mate. Now it wants me to pick the cam's path. This is the side of the cam. So if I pick any of these flat faces, it'll wrap all the way around tangentially. So I could just click a flat face, and now it's selected the cam, and you can see it turn the outer faces green. So it has all those faces. It knows they're there. Now it needs the cam follower's outer face. So I could grab this outer face here, and now it'll touch the two together. Now I just have to hit the green check. And if I want to see what we've done here, I can drag our pulley, and you can see now that follower follows the cam. Super useful if you're doing any kind of cam motion things, any kind of cam controlled things, like maybe an engine with valves. You can use a cam mate. All right, now if I want this thing to go back and forth and follow this wheel around and have this slot in this hole and this peg in this slot, we can use the slot mate to do that. So let me go back to the mate tab and grab the mechanical mate tool and use the slot mate. The slot mate works pretty similarly to the cam mate. We pick the slot's inner face there, and we pick whatever kind of peg or other faces that we want to be inside the slot. In this case, we've got this cylindrical face here. Now we've got some choices we can make. We could leave it free. That means it's free to move from side to side in the slot. We could make it centered in the slot. We could give it some distance along the slot, or we could give it some percentage along the slot to control where its position is. In this case, I want to leave it free to go off of both sides of the slot. And I don't want to lock down the rotation either. The thing in the middle here is going to be free to rotate around as we move the wheel. So I'll just hit the green check and green check again to close the mate tool. And now if I move this pulley, we can see, oh, let me grab it by the little knob here maybe. Now we can see the slot mate makes this green piece follow the wheel as it moves around. The cam mate makes the follower move around, and the belt chain feature makes all the pulleys move as if they were connected with a belt that's 1950 millimeters long. So that's kind of it for this demonstration. Let me close this file. And now I'd like to go over the gear mate and the rack and pinion mate and the screw mate. In the first example that we see, we're going to see the gear mate, and we're going to also see the screw mate. I'm going to make it so that when we turn these gears, this nut goes back and forth on this shaft as if it's threaded on there. Maybe it's some kind of limiter or something in real life, but we're just going to use the screw mate to show how that works in here when we're in this one. I'll open that one first. I double click to see my old documents, and there's my gears. At first, you can see I have this thing mated down concentrically to the shaft. I also have a parallel mate with the right plane of the assembly so that this can just go back and forth like that and not spin freely. If you ever want to see what mates are on a component, a great way to do it is with breadcrumbs. If you click on anything, breadcrumbs pop up here in the upper left-hand corner. These are breadcrumbs. If I hover over, this is the part I clicked on. These are the mates that are on that part. And if I hover over them, it highlights them in the feature tree. I can even do you one better. If you want these breadcrumbs to come right to your fingertips, if you click on something and you hit the D key, D is in dog, they'll come right to your fingertips, and we could click on a mate. Maybe I want to take this parallel mate off for some reason. Well, I could click on it. I could suppress it. I could edit it. I could even hit delete from my keyboard and delete it. I could right click on it and delete it. And that's all done without having to dig through the feature tree to find mates. Those are breadcrumbs. I really love them in assembly files. They're super useful. You can even do crazy things. Like if I wanted to change the shape of this nut, I could click on it, hit the D key. I could find the extrude that I clicked on, and I could see the sketch that made that extrude. If I wanted to edit that sketch, I could click on it and choose edit sketch, and it'll throw me into that sketch, and I could change that part. Breadcrumbs are super duper powerful. I really like them. All right, let me get out of that. That was just an extra bonus tip. Now, before we apply a gear mate, we want to make sure that our gears are not in an interfering state. If we have them interfering with one another, they'll always stay like that. The gear mate keeps them spaced equally from where they were initially. So try to make sure none of them are crashing into each other. There, that's pretty good. And up here, that's pretty good. It's kind of crashing in the middle a little. There. Right about there, let's say, is perfect. Try to get them in a position that you like the way they look. Remember, when you use a gear mate, it's not going to actually show you like the lash of the gears. It's going to keep them evenly spaced. All right, I'd say that's pretty close. Now, another thing we'll need on all of these gears, we have a couple circles sketched. If I turn the sketches on under the view eye, you can see all these extra circles. These ones are the pitch line of the gear. We need to have a circle that is the pitch line of the gear. It's going to help us when we're making the gear mates. That'll be what we select to mate it down. All right, let me go to the mate tool and choose the mechanical mate tab and add some gear mates in. I can grab the pitch diameter of this gear and the pitch diameter of this gear. And now you see next to my cursor, there's a mouse and the right click button is showing the green check. If I want to hit the green check, I can just right click right now. And I made that gear mate. The first one's done. Now, let's see, I want to mate this one by its pitch circle and this one. And then, oh, I have to choose the gear mate still. I didn't tell it what kind of mate. And because I picked the pitch circles, it knows what diameter the pitch diameter of the gears are. That's how it makes sure they move at the certain ratio. If you wanted to change these values, you could type in a different value here by hand. And if you move the gears and you notice they're spinning the wrong way, you have this reverse button. You can reverse it if it's the wrong way. Let's see. I'll start to turn it. It looks like those two are turning the way that I thought they should. So that's a good sign. I'll hit the green check and that next gear mate gets made also. All right, now I'll make another gear mate between this pitch circle and this pitch circle. Bam. And hit the green check. We'll test it one more time to make sure they're all turning the way I thought they should. Yeah, that looks pretty close. And then we'll make one more gear mate. I'll grab the gear mate tool again, and I'll grab one of these pitch circles on the outer gear, and I'll grab this outer ring's pitch diameter there, and I'll hit the green check and green check again. And now we should be able to drag this outer ring and see all the gears move. That's pretty good. Let's see what it looks like when I move the inner gear. It's kind of doing its thing. It might help if I turn the shadows off. It might help it render a little faster. So I'll go up to my monitor, turn the shadows off, and maybe I even turn the sketches off because we don't really need them anymore. That's a little smoother now. We can see how that planetary gear mechanism works just because of those multiple gear mates that we added. It's not very tough to add those. The key is to have the pitch diameter drawn in on your gear. That'll make your life a lot easier. Now I want to, as I rotate this, I want this nut to act as if it's threaded on here. I want it to move closer to the, I want it to be able to move closer to the gear and further away, depending on which rotation I'm doing. Maybe once it gets to a certain distance, it'll stop this whole thing from rotating. I don't know. But to add a screw mate to this, all we have to do is go up to the mate tab, choose the mechanical mate, and I can add a screw mate. The screw mate just needs the circular faces where the screw is happening. So if I grab this circular face and then this inner circular face of my nut, That's enough for the screwmate to work. Now we have to tell it information about the threads. How many revolutions per inch does your thread have? Or what's the distance per revolution? So maybe every 3 inches there's one rotation here, something like that. And if you see it's going the wrong way, if I turn this and I don't like the direction that it's moving when I turn it, I could hit the reverse button. That's the screw mate. Now I could even grab this and drag it to turn the gears. And if I turn the gears, you can see the nut moves also. That's thanks to the screw mate. So that's it for this example. Now we're going to see the rack and pinion mate. It's pretty straightforward also. Let me go ahead and open up the rack and pinion file. So you will have to have some additional mates to get these things to behave. Right now, there's a parallel mate with this in the ground somewhere. And there's also a mate keeping these coincident on their back faces, but they're allowed to move around otherwise. We will need our pitch diameter circle. And we will also need our pitch on the rack. So I have some sketches in here. If I go under the view eye, we can turn our sketches on and we can see we've got this sketch that has the pitch diameter of the rack. Well, it's not a diameter, I guess, but the pitch measurement is in there. And we have the pitch circle of this gear. Now I know that the distance for the pitch circle, if I click on this line, I can see the measurement in the bottom status bar here. It's 76.2 millimeters away. So I'm going to put a distance mate on from here to the center point of the gear. That'll still let it rotate. I can grab them both while holding down control. As soon as I let go of control, there's this nice fly out menu where we can add mates. I'm gonna grab the distance mate and tell it to be 76.2 millimeters away. Great. And now I could hit the green check or right click. And we've made that distance mate. But you can see they still don't move one another. We still have to move them manually. That's where we need the rack and pinion mate. And much like the gear mate, if we start in a position where they're interfering, it's going to stay like that. So let's not do that. Let's make sure they're not interfering. That's pretty good. And then I'll go to the mate tool. I'll grab the mechanical mate tab. And I'll add the rack and pinion type of mate. Now we need a linear edge or a flat face from the rack. I'll grab this outer linear edge. And we need our pitch diameter of our gear. So I'm going to grab this pitch circle. And now if we move our gear and we notice that, oh, they're not moving the way we thought, well, there's a reverse button in here too. I'm going to hit the reverse button. Oh, let's see if that behaves better now. Yeah, it looks like it's rolling the way we like. Okay, let me hit the green check again. And now we have a rack and pinion mate. And if I move either the gear or the rack, you'll see that they move one another. That's pretty great. That's it for this example. So we saw the gear and the rack and pinion and the screw mate. Let's see one for the universal joint. If you want to see all of the components in the universal joint, you don't need this mate. If you're going to mate all the other components in, you can do it without having this mate involved. If you don't want to mate the spider and the pins in there, you can use the universal joint mate to make these have relations to one another like they're in a universal joint. Let me go ahead and open up the file. I've added a sketched point to this part that's right in the middle of its holes. That's where the U-joint's center point would be, where everything rotates around. We can put that into the U-joint mate if we want to. It's not a mandatory part. There is a mate keeping this coincident with this bottom face. And there's also, that's it. There's just a mate keeping it coincident with that bottom face. So I'm going to move this into a position that's pretty close to what we want. As far as the rotation wise, because remember how the gears would stay wrong if we moved the gears and they were already intersecting. Well, this is the same way. It'll stay wrong too. All right, that looks pretty good. Now I'll go to the mate tool and I'll go to the mechanical tab and I'll choose the universal joint mate. All I need are the outer cylindrical faces of these. So I'll grab that outer cylindrical face and this outer cylindrical face. And if I want to have the joint point defined, that would be the center of the U-joint mechanism. I could say define joint point, and I could grab a sketched point where the middle of that happens. Now, when I hit the green check, you can see we've added a U-joint mate. And if I turn the one, yeah, there's some interference still. But now they turn together as if they were connected by a U-joint just because of that one mate. If we wanted more accurate motion in here, we could put all of the other components in and it would move just because of the normal mates that are on them. You wouldn't have to use an advanced mate. You could just mate the spider and the pins in, and then it would rotate just because of those being there. So that's kind of it for the U-joint mate. You can see what we did there. Pretty straightforward. All right, now we're going to take a peek into the advanced mates tab. I want to show what the profile center mate does, what the symmetric mate does, and what the width mate does, all with this example that you see here. Let's pretend maybe it's a hanger for a hoist or something like that. It is just mainly for demonstration purposes. Let me get into that file. Cool. So right now I have this pipe mated down all the way. That's the mated, that's the first base component of this assembly. All the other things are just tossed on the floor like it's a sandbox here. If I want to mate this square piece to the end of this and have it be directly centered on there and everything, I can use what's called the profile center mate to make that happen. Check it out. If I go to the mate tool and I go to the advanced mate tab, we can choose profile center, and I could grab this face and this face, and it puts them centered on each other. It mathematically figures out where their centers are and puts them right together. And it also puts them coincident. If we want to have a tiny gap between them, we can tell it to have a small gap between them in the property manager over here. Maybe we want a 3 millimeter gap for some reason. Oh, and we can see it moved the wrong way. So I also have this flip dimension. That checkbox will make sure it flips it so it's a gap. By default, it's set to 0. It makes it coincident, but we can include an offset if we'd like. I'm just going to hit the green check, and now that mate is added. This thing is still free to move around, so we'd have to mate it down. Well, it's free to rotate. If we want to fix down the orientation, we'd just have to add a parallel mate with, let's say, the top plane. We'll make a standard parallel mate there. Now the rotation's locked also. There is a lock rotation button in the profile center mate, but it might have locked at whatever random orientation it was in. The profile center mate also works for wild shapes. Like if you have a shape with bolt holes in it, that's okay. It'll still work. We could go to the advanced mate tab and grab the profile center tool. I'm going to tell it 0 millimeter offset, and I'll grab this face and this other face. And you can see, oops, it put them in a little backwards. Well, that's why we have the, oh, that's interesting. Well, I guess in this case, I'm going to have to manually rotate. Oh, we have a mate alignment button. My bad. Check that out. We can flip it around with the mate alignment button. No big deal. And even though there's these holes on this, it still figures out the center of each face and mates them together. That's great. There's the lock rotation checkbox that I mentioned. If we wanted to lock it down at this random angle, we could. Now, remember how I showed mate shortcuts? If you select multiple things while holding down control, like those two faces, as soon as you let go of control, there should be a little fly out menu that pops up. And you can add mates from this fly out menu. Let's make those two faces parallel to one another so that everything lines up. If you know what the different advanced mate symbols look like, you might see the advanced mate show up in those shortcut menus too, like the profile center mate. Watch this. If I click this face and then I control select this face, as soon as I release control, I can see there's the symbol for the profile center mate. I can add it right here without having to go into the mate tool. And we also have the ability to choose which orientation this thing comes in. If I hit these arrows, it'll rotate the orientation because there's some choices this time. Those arrows exist in the mate tool as well. Let me hit the green check, and now we've added a profile center mate to lock those down also. Now that's enough about the profile center mate. It's cool and all. Let's show the width mate. If I want this thing to be in the middle of from here to there and slide back and forth, I could use the width mate to do all that fancy stuff. I'm gonna put a concentric mate on these first. If I just hold down Alt and click a circular face and start to drag, it'll do smart mates. I can drag it over another circular face and let it go, and it'll put a concentric mate on. Now I want this thing to stay in between the end plates. I don't want it to keep crashing through. I want it to stay in between. I could use a width mate. A width mate just takes 3 to 4 selections. I do like to go into the mate tool anytime I'm going to use an advanced or mechanical mate because it helps you see what you need to select. If we go into the advanced mate, I can grab the width tool. We could grab the outer faces. And then we could grab the inner faces. And the order shouldn't matter a whole lot here. Now, we've got some choices we can make with the width mate. By default, it's set to center this thing in there. It'll be locked in the center. We could leave it free to bang off the sides. We could dimension it some dimension along the way, or give it some percentage along the way here. Also, I'm going to choose free for this one. And when I add that mate now, when I try to drag this through that end plate, it can't. It'll stop because of the width mate. See that? The width mate is stopping it. It's free to move along this, but it'll stop at the end faces. Maybe I even make this face and this face parallel to one another, so it doesn't rotate around anymore. It's still free to move back and forth though. So that's one use of the width mate. Now let's say I wanted to have one of these things on one side of this and one on the other side of this, and I wanted them to be in exactly the same spot. We could probably mirror these components, or we could use symmetry mates and have 2 of these components. If I want to make another component, I can copy this one just by holding down Control and clicking and dragging it. Now I have a second one out here. I can grab this flat face and mate it to this flat face. And I can grab this face and mate it to this face with a coincident mate. Great. Now, if I want them to be acting similarly around a plane, like if I want them to be in the same spot when I move them around, I can add the symmetry mate. We might even need 2 symmetry mates to make them stay in exactly the same orientation. So if we go to the mate tool, under the advanced mate tab, you can see the symmetric mate. I have to give it a plane where it's symmetrical around. Let me choose the right plane. Let me choose the top plane this time. There, I want it to be symmetrical on both sides of that plane. See the top plane? So I want the top plane as the symmetry plane. And then in my mate selections area, I could grab like this face of that one, this face of that one, and it's going to make sure that those faces stay in a symmetrical area. We might also have to add one more symmetry mate for these top faces. Let's see how it moves when I drag the one around now. Now they behave. And when I move them, they stay the same distance from that top plane that we had. It looks like they're not staying lined up this way though. So I'm going to add another symmetry mate. And I'm going to choose the top plane once again. and I'll grab the tops of these. Now it knows that those have to be symmetrical also. Now, if I move one of these around, you can see they both move around to the same spot. So if we found that optimum position here, we'd be sure that they were in the same spot because of the symmetry mate. If I like mate this one some distance away from this edge, like 20 millimeters, now this one's also 20 millimeters away. I can see there when I select both the faces, it's also 20 millimeters away. Great. All right, so that's the symmetry mate, the width mate. I have one more use of the width mate to show you all. I'm gonna make one more of this part. I'll hold down control and click and drag it. Now we've got another copy of it out there. Now, if I wanted this hole to be right in the center of this plate, I could do it with two width mates. I could grab, so width mate can do it with 4 faces, like we showed for the initial one, or you could have a cylindrical face and 2 planar faces. So I could use a width mate here between these faces, and you can see it even brings the width mate into the shortcut toolbar. That's the symbol for the width mate. Now that's locked in the center. That hole is in the center of those faces. Nothing's holding it this way though, so I'll use another width mate to hold it that way. If I grab this face and this face and this face and this face, you can see the width mate just pops up in the shortcut toolbar. Great. All right, so that's the symmetry, profile center, and width mate. Let me close this file. Now, let's see a use case for the path mate. You might someday have something that wants to follow a path. You can draw a path out, and as long as your part has a sketched point in it, you can make a path mate and make that part or assembly follow your path. Let me find that file here. Path mate. So I've got this bulldozer unit, and right now it has no mates tying it to this spline sketch. A path mate can also work on a non-spline if you had like a bunch of like a slot or something. You just have to use the selection manager to grab the whole loop. The selection manager is when you're in the property manager, just a right click away to get to selection manager. This one's a little easier because it's a spline. I can just grab it. All right, now if I go to the mate tool and tell it I want to add a advanced mate, I could add a path mate. I've sketched this sketch on the bottom of my bulldozer that has a point right in the middle. We're going to need that point, and we're going to need this path. So I'll go to the path mate. It tells me component vertex. It could also be a vertex of your model. If you didn't sketch a point, it could be like a vertex also. I'm going to grab this point. And then my path selection, if you had something that was not splined here, you could use the selection manager to grab all of it. I'm just going to grab this spline And now we get some other options under the path mate that are all pretty interesting. So where is it at on the path? We could give it some distance along the path, and that would put it at some arbitrary distance along here. We could give it a percentage along this path, and that would put it at some arbitrary percentage, or we could leave it free to move around the path. Right now, if I try to drag this thing around, you can see how it doesn't follow the path. See how it like moves weird? Pitch yaw control is going to make it so it looks like it moves and steers around that path. So instead of leaving that free, I'm going to choose follow path. And it puts some little triads up to show me how it's going to follow the path. If it follows it by the X direction, that's going to be sideways. That's not right. It looks like the blue direction is what I want. See the blue part of the triad? So I'll select the Z, and now that will have to follow the path. So it'll try to make it point the right angle as we're going around the path. See that? It kind of looks like it's driving a little bit more. Roll control is similar. If we had hills where it was going up and down hills, or if we notice it's going side to side and rolling along this path, we could turn roll control on and give it an up vector. But I've taken care of that already with a parallel mate between the bulldozer and the top plane, so it won't do that. If I hit the green check here, we've added a path mate, and now I could drag the bulldozer along, and it looks as if it is driving along this path thanks to the path mate. So that's kind of it for this one. Let me just close it and get back into the PowerPoint. Now we've got a few more different advanced mates to see. We're going to make one that is a linear coupler. A linear coupler can be made between linear edges. Anytime you want one thing to move and you want something else to move with it, you could use a linear coupler. You can give it a ratio, or you could have it move 1-to-1. That'll be our first example here. So I bring the rack and pinion back in. This thing's already got a rack and pinion mate. But now I want this top thing to move opposite to the bottom thing, kind of like it's on the top. I could add another rack and pinion mate, but that might make it think a little harder than it needs to think. If I drag this to the start position that I want it to be in, let's say something like this, I could use a linear coupler mate to make it so when this one moves, this one also moves. I'll grab the mate tool. And choose our advanced mate tab, the linear coupler mate. Let me explain this selection area. So these could be linear edges or faces. I'm going to grab an edge from this one. And then this next box is if you want any other components to move with it. So if I had something else that I wanted to move with this thing, I could grab it in this next area and it would move along with it. Now this is the next edge I need. So I'll grab this upper one. And the way the arrows are pointing are showing you how it's going to move. So this is good in this case. If I wanted it to move in the same direction, I'd have to hit reverse and then they'd move the same way, which is just kind of they move along together. You could use other mates to make that happen. And if you want to change the ratio that they move at, maybe if I moved one of them 1 millimeter, I want the other one to move 5 millimeters. We could make that happen here also. If I just add this mate, now you can see they move together. That's thanks to the linear coupler mate that we added. That's all for that one. Now I've got a couple things to show with the bulldozer. I'm going to bring the bulldozer back in. We're going to do a limit distance mate. This is incredibly useful if you have something like a hydraulic cylinder that you want it to stop when it gets to the end of its stroke. You can tell it how far it's allowed to move, and it'll stop where you tell it to stop. We also have a mate that will let you limit angles. Let's say if I wanted this bucket to only move through a certain range of angles, we could use this mate to make that happen. So let me open up our bulldozer. You can see right now, I don't have anything stopping these cylinders where they're supposed to stop. See how I can pull them through where they're supposed to go? Well, that's not great. If I want to use a limit distance mate, I could make it so that they stop where they stop instead of having them be able to pull out like this. If I go to the mate tool, I think we might actually have to be in the assembly that we want to mate. So this is a sub-assembly. I'll have to open my sub-assembly. I can do that from the feature tree. Open sub-assembly. There it is. Now I want it to stop when it gets to the end and stop when it gets to the close point also. I can use a limit distance mate for that. If I go into the mate tool, underneath the advanced mates, I can choose this one. And I'll grab, let's say, this face and this face. And now it tells me it's at 1 inch right now, 1 inch away. What's the maximum distance I want it to be able to move? Let's say the maximum distance for this one is 22 inches. And hit the green check, hit the green check again. Now it'll go from 1 inch to 22 inches and stop. It stopped right there. I can't drag it any further. When I push it back in, it stops there also. I can't push it any further. That's thanks to the limit distance mate. If I save this thing and then go back into the bulldozer, it will no longer be allowed to move wherever it wants. It'll stop when it hits the limits. So now it stops there and it stops here. When we get to the bottom of the stroke there, it stops. That's thanks to the limit distance mate. Now, if we wanted this bucket to stop at certain angles, we could add a limit angle mate in. See, I already have one in here. I'm going to show how I added it though. So I'm going to delete the limit angle mate out. Let's edit it just so I see which faces and what angles I told it. So I told it it could go start at 135 degrees and then go all the way down to 60 degrees between those two faces. Let me just delete that mate out of here and I'll re-add it so you can see how that happens. So right now, nothing's stopping us. We could rotate it all the way around. That's not what we want. If I go into the mate tool, I can choose the advanced mate tab and use the limit distance or the limit angle this time. And grab the faces that I'd like to have a certain angle. This could also be planes. Planes are extremely useful to grab also. Let's say it starts at 135 degrees. I'm going to have to flip that dimension probably. We might even have to mess with the mate alignment here. We've got two boxes to control that. Then we got a checkbox and these buttons down here. All right, that looks like the right start orientation. Now I want it to go until it can be all the way down to 60 degrees between those faces. And because of that limit angle mate, now it'll stop when it gets to 60 degrees and it'll stop when it gets to 135 degrees. It's pretty great. Limit distance and limit angle are extremely useful, especially for hydraulics. That's all I've got for advanced mates. Now there's one more helpful tool I want to show. Underneath the move component tool, we can turn physical dynamics on. Physical dynamics are extremely useful if you're not sure how to mate something together, but you want to see how one thing moves the other thing. I'll open this Geneva wheel example first, and I'll use the same tool to show you how it could work instead of mates for these things. It's just the physical dynamics tool underneath move component. All right, so this thing would be pretty hard to mate down in a way that made it behave. Whenever this little post goes into this slot, it's supposed to make this move forward one notch, pause, and then move forward another notch. It doesn't have any mates to make it do that right now. I can go into the mate tool and I can, oh, this isn't a mate. Remember I said this would be pretty hard to mate. We could try to slot mate or cam mate. It wouldn't work right. So we're not sure which mate to use. That's a great time to use physical dynamics. Under the assembly tab, there's the move component tool. If you turn on physical dynamics, SolidWorks won't let things crash through each other anymore. And if I start to drag this thing, now whenever it touches that, it's going to rotate it ahead one. I can just rotate it around like so, and you can see every time it hits that, it's going to rotate that one notch further. There's no mates making it do that. That's just thanks to the physical dynamics tool. This one actually likes if you grab the, I'll do it again. So it's move component, physical dynamics. It likes it if you grab it by this point a lot better sometimes there. You can also move a component with the triad in this world. If it's acting funny, you could right click, rotate component is an option, but you can see how that could be useful to test out this kind of mechanism. Let me show it on some other use cases here. And then that's it for me. So we've got these nested slides. Right now, there's nothing to keep them locked in. See how they can go wherever. We could add slot mates to all of those, or I could go into move component, turn on physical dynamics, and now they work. I didn't have to add any mates. It's just that easy. And one more. Hit R for recent documents. If you want to see what the gear lash is, if you're trying to see how much they move before they push each other, physical dynamics will show you that. Right now, remember how the gear mate just keeps them like evenly spaced the whole time and they might never touch? Well, if I turn on physical dynamics, now one of them has to actually hit the other one to move it. So we can see how much lash there is in this gear mechanism. Physical dynamics is extremely useful for hard to mate mechanisms. All right. Are there any questions? Let me see. I think I saw some chats.